Let's determine the voltage regulation of three-phase transformer. Here the transformer is delta star connected and the loading condition is given as full load pointed power factor lagging. As the resistance and reactance are given referred to the secondary side, first calculate the line current. The line current is equal to S upon root 3 VL2. So I got this line current as 131.22 ampere. As the secondary is star connected, the secondary phase current is equal to the line current. So it is 131.22. The secondary phase voltage is line voltage of secondary divided by root 3. So it is a 254.03. If we calculate the sin phi under root 1 minus cos square phi, it comes to 0.6. The regulation formula is x ip2 re2 cos phi plus xe2 sin phi upon vp2 into 100. As the power factor is lagging, this line is a plus. So we have to determine the regulation at x is equal to 1 and power factor is equal to 0.8. Substituting all the values, I got the regulation as 8.26%. Let's determine the voltage regulation in three-phase transformer. Here the transformer is a star delta connected. The regulation is to be calculated at full load unity power factor and the resistance and reactance are given referred to the secondary per phase. First calculate the line current of the secondary S upon root 3 VL2, it comes to 131.22. As the secondary is delta connected, the secondary phase current is equal to line current upon root 3, it comes to 75.76 ampere. The secondary phase voltage is equal to line voltage, that is equal to 440 volt. Sin phi is equal to 1 minus cos square phi, but the cos is given as a 1, so it is under root 1 minus 1 square, it is 0. The percentage regulation, the term related to the sin phi is absent, so this is the formula of percentage regulation. Substituting x is equal to 1 and cos phi is equal to 1 in this formula and substituting all the values, the regulation comes to 0.86%. Let's determine the voltage regulation in three-phase transformer. In this three-phase transformer, the connection type is given as a star delta, secondary is delta connected. We have to determine the regulation at full load 0.8 power factor leading, and all per phase values of the resistance and reactance referred to the secondary is given. So first calculate the IL2 S upon root 3 VL2. This is the line current. As the secondary is a delta connector, the secondary phase current is equal to line current upon root 3. So this is my line current. The secondary phase voltage is equal to Vp2 is equal to VL2. Phase voltage is equal to line voltage. It comes to 440. Calculating the sin phi 1 minus cos square phi, it is a 0.6. The regulation formula is this. In this, the middle sign is the minus as the power factor is a lagging one. So substituting the value x is equal to 1, cos phi is equal to 0.8, the regulation is minus 1.38%. Let's determine the voltage regulation in three-phase transformer. In this case, the transformer is given as a star delta and the loading condition is full load 0.8 power factor lagging. So first determine the secondary line current as the resistance and reactance are referred to the secondary side. So IL2 is determined using this formula. As the secondary is a delta connector, the secondary phase current is equal to line current upon root 3. It comes to 75.76 ampere, and the secondary voltage is secondary phase voltage is equal to the line voltage, so it comes to 440. So sin phi is equal to under root cos square phi, it is 0.6. So regulation formula is this, because this is a plus sign as the power factor is lagging. Substituting all the values which we calculated above, the regulation is 2.75%. Hello, once again let's determine the voltage regulation in three-phase transformer. Here transformer is delta star connected and the loading condition is given as a full load 0.8 power factor leading. So first find out the secondary line current using this formula, S upon root 3 into VL2. This is 131.22. As the secondary is star connected, the secondary phase current is equal to line current, whereas secondary phase voltage is equal to line voltage upon root 3. Calculating sin phi by under root 1 minus cos square phi, it is a 0.6. Here we have to determine the regulation at a leading power factor. So in this formula, this sign is a minus. All values are the phase values because RE2 and XE2 are phase values. So calculating the percentage regulation at x is equal to 1.8 power factor leading, substituting all these values in this formula, the regulation is minus 4.13%. Let's determine the voltage regulation in three-phase transformer. Here the transformer is a delta star connected The loading condition is given as a full load unity power factor. So first calculate the full load line current of the secondary. So IL2 is equal to S upon root 3 VL2. It's 131.22. As the secondary is star connected, the phase current is equal to line current. So it is 131.22, and the secondary phase voltage is equal to phase line voltage upon root 3. It comes to 254.03. Here power factor is given as a unity. Hence sin phi is equal to 0. So the percentage regulation, the term related to the sin phi is equal to 0. Hence x IP2 RE2 cos phi upon VP2 into 100. Substituting all the values, the regulation is equal to 2.58%.